Hello and welcome back to my channel Network Shark. My name is Bappa Mahanta and today we are going to understand switching concept as well as the data flow. Switching concept means what? Switching concept means why the device is required. We all know that in every organization there are so many devices are available. Okay, so with the help of switch we can connect all these devices together and share or exchange resources between or data between all the devices. Okay, we can exchange, we can share data, not only data but also we can share our internet connection, we can share our printer as well as different scanners or whatever ip phones, everything we can share over the network, right? So to create a network, a local area network, switch is really helpful. Not only local area network, in every section, every data center you can say, or enterprise companies or small medium companies, switch is very much useful, right? So switch, to understand about switch, let's go forward to the next slide. Here we can say that there are two different types of switches are available. One is manageable and another two types of are, sorry, one is unmanageable and remaining two are manageables. Okay, so what is the purpose of unmanageable type of switches? Unmanageable type manage, you can't manage this type of switches, you can customize these switches. Okay, whatever is predefined given inside the switch, based on that this switch will work. Okay, this switch will work. If you want to access the CLI or GUI mode of that switch, you can't be able to do so. Okay, but this type of switches are basically used for small medium or in your house or maybe small medium companies. Okay, but if you are working in a large company or in a data center or some big organizations you are working, then at that point of time manageable switches are required. Why? Because to provide extra bit of configurations as per the requirement of your organization. So here you can see this is layer 2, this is layer 3 switch, manageable switch. So why layer 2, layer 3? What is the meaning of it? These terms came from OSI model. Okay, Open Standard Open System Interconnection, OSI. So in based on OSI model, there are 7 layers. We all know that: application, presentation, session, transport, network, data link, and physical. So layer 2 is known as data link layer, and layer 3 is known as transport layer. What is the difference? Layer 2 only work with MAC address. Layer 3 work with network address. In short, if I give you example, MAC address is the physical address of a computer, media access controller. Every device has its own MAC address. Okay. And layer 2 device, all the layer 2 device only understand MAC. They doesn't have any idea about IP address. So whenever any data or any frame passing through the switch will not going to understand anything about IP. It will only understand MAC if it is a layer 2 switch. But if it is a layer 3 switch, this type of switch also capable, apart from MAC address, this type of switch also understand the concept of IP. That is the reason why this type of switches are known as multi-layer switch. So these are the switch. This switch can act as a layer 2 as well as layer 3. Okay, so these are all Cisco switches. This one is D-Link switch. This one is Cisco Catalyst switch. The series is 2960. Okay, and this one is 3560. So 2960 and 3560. Okay, this is multi-layer switch. So let's understand all these ports and all. Okay, one by one. So see, this is Cisco the brand, and here these things are indicators. Okay, indicators means LED indicators. Some system LEDs are there, some redundant power supply indicators are there. Okay, some states indicators are there. State means this this interface state. Okay, RFC means redundant power supply. So if this switch have multiple power supply unit, then and these are in active state, So this link will be blink. Okay, apart from these three, there is power over Ethernet, PoE, power over Ethernet. Link is also available. Okay, duplex indicator LED is also available. Speed indicator light is available. So there are all total six number of indicators are there. Okay, on the basis of their lighting, like if it is in green, that means it is working absolutely fine. If it is the color is amber, okay, so there might be some issue happened. So based on this light indicators, you can troubleshoot the device. Okay, and here you can in the below section you can see it's a mode button. Okay, so mode button is nothing. If you press this mode button 10 or 15 seconds, then you will get the ROM monitor mode of this switch. And why ROM over there? You can break user passwords, or you can recover. I mean, if you have taken the backup of your internet work operating system earlier, then in the ROM monitor mode you can restore it. Okay, so let's move ahead. These interfaces are basically fast Ethernet interfaces, and 100 Mbps is the speed of the fast Ethernet. You all know that. These are gig ports. So gig ports means gigabyte, gigabit interfaces. So it will give you around 1 Gbps to 10 Gbps based on their category. These are these um, ports are actually known as SFP ports. SFP. These SFP ports are used to connect fiber channel. Okay, fiber cables, which will give you more what? More distance coverage as well as speed. Okay. Mm. The full form of SFP is small form factor pluggable. Okay. So these ports are basically responsible to provide you the fiber cable connectivity. Okay. This is the front panel and this is the back panel. Always remember the yellow mark is marked actually around this port. That means these ports are supported what? Power over Ethernet supported facility. PoE. Here also power over Ethernet. Okay, power over Ethernet means what? If you connect any IP phones or camera or something like that, this switches will also provide power also. Okay, you all know that in RJ45 port or connector, we have eight number of pins, right? So out of that eight, four are responsible to receive or distribute data, and remaining four are for power. One, three, two, six. These four are for data and remaining are for power. So if you go to the back panel, you can see this is the uh, console port. Okay, with the help of this port, you can configure this switch from any PC. Okay, so this is the power unit, and this is nothing, just a the fan heatsink type of things. The warm air or is coming out from inside. Okay, and this is multi-layer switch. All these are 48 port switch, and these are SFP ports for fiber, and yellow border you are showing, that means all are providing power over Ethernet facilities also. Okay, so these are the basic introduction. I will later on I will create a large or in detail on all or we will deep dive into that switch section later on. Okay, so let's understand. So let's go to the next topic. Just a minute. Okay, yeah. Let's understand the data flow. This is a very important concept you need to understand. Okay. Okay. Let me introduce this topology. As you can see, a switch is available. It's a layer 2 switch. That means what? This switch only have a MAC address table. Okay. On the basis of MAC address, this switch will send or forward frames. Okay. And we have four PCs and one server here. Okay. So four PCs and one server we have, and all these devices are layer 3 device. Why? Because they understand the IP. This is the IP address C 192.168.10.1, 10.2, 10.3, 10.4 and 10.5. So basically it's a local area network and all the devices are connected with each other with the private IP addresses. And these are the MAC address. Okay, A, B, C, D I have taken as an example, but in real scenario you will get a 12 character 48-bit hexadecimal value for the MAC address. Okay, so let's understand how the connectivity will be established. We all know that we put IP address, okay, and ping started, everything started automatically. But as a network engineer, you should know the concept how the connection has been established. Okay, so let's start. So I am creating a table here. 1, 2, 3, 4. Okay, fine. So what is this? It is nothing. It's a MAC table. It's what? It's a MAC table. It's a MAC table of the switch MAC table. Okay. In the MAC table, what kind of information switch used to store? The first is VLAN information. VLAN number first. Second, MAC address. Third, interface or port, you can say. Interface or port. Okay, in short. And third and fourth one is, sorry, type. Type means what? Type means way of learning. How it is learning, what is the process. Okay, this is not required, so I'm just deleting it. Where table, yes. Where is the option? Here it is. Delete column. Okay, so VLAN number, MAC, port, and type. These are the four basic fields which is inside MAC table. Okay, and this PC do what? This PC, this PC generate ARP table. What? Address resolution protocol. That is ARP. It's a protocol which is help to resolution from IP address to MAC. If this PC have IP address, then ARP will automatically resolute its MAC address. Okay, so this is basically what? This is basically ARP table, and this server also maintain the same. It also has ARP table. Okay, so what happened? See, ICMP is a protocol, Internet Control Message Protocol. Okay, so whenever we are doing ping, okay, at the very first time, see CMD, if I go to CMD and doing ping www.google.com, so the once I hit enter, see I am getting the reply in a fraction of second. I am getting the reply because I am connected with the internet and Google is giving me the reply. So what happened here? ICMP is a protocol which is providing such things. So ICMP protocol only IC, see ICMP protocol doing what? ICMP is a protocol which generate two types of message. One is echo request and second one is echo reply. Echo reply. So at the very and always remember ICMP is a layer 3 protocol. Okay. So what happened? ICMP generate a data, okay, that is echo request. It is requesting basically generating a request. It's generating a request, okay. But ICMP will not going to achieve get it, the echo reply without the help of ARP. Why? Because ICMP is a protocol comes under IP address. Okay, ICMP initiate the echo request, then handed over the task to IP address, IP protocol, internet protocol. Then what IP do? This is IP address. Okay, so as per you all know that this is the IP already written inside the PC. Subnet mask is given. Default gateway is already written. Everything is written. So on basis of that configuration, what IP will do? IP will check that my source IP is this one is source and my destination IP what is I'm able to ping. I am started. See here, I am started here. I have given a command called ping 10.0.0.192.168.10.5. This is the IP address of this server. Okay, so here I am started pinging just like I used to ping here, ping google.com. Okay, and I'm getting the reply. Here also I have started ping. I have written in the command prompt of this PC 10.192.168.10.5. This is the IP address of the server. But once I hit ping, ICMP generate a echo request message. Okay, and hand over the task to IP address. IP just seeing that this is the traffic generated by this PC. Okay, that means the destination IP is 192.168.10.5. This one. So it is what it is. IP is just searching that the destination IP is the remote one or it's a local one. So it's a local one, right? So if it is a remote one means it's a different network IP. If I able to write 20.5, if I try to ping, then IP will look for the gateway. Okay. So here gateway means router IP. It will if gateway is not found, then the packet will immediately get discarded. Here 192.168.10.5 I have tried to ping. That means it's quite accessible. So once IP will forward the data packet through the switch, IP will check its ARC table. Okay. So is there any information about the destination MAC address? My MAC address is A. And is there any entry available in the ARP table about the destination MAC address, which is E? So in the ARP table, basically, what are the information stored? MAC address information stored, IP address information stored, and the time. Three type of informations are stored in the ARP table. Okay. MAC address means source MAC, destination MAC, source MAC, destination MAC. Okay, source MAC and destination MAC. About IP, source IP, or you can say target IP. Source IP and the target IP, right? Target IP or destination IP and the timer. Always remember the by default ARP, the maximum age time is 4 hours. So up to 4 hours, any computer will store the record of ARP. Okay. So one is written when timer started. So whenever any IP will look to its ARP table, that what that entry is available or not. If the entry is available, then fine. It will send data to this uh, what server. If the entry is not available, then by default the entry is not available. Then what happened? Then it will perform a task. The name of the task is ARP. ARP. ARP task or ARP process. What is the name of this process? ARP process. In the ARP process, ARP protocol is responsible to convert IP address, not convert. ARP is basically hold the record of IP and MAC both. So once the ARP also works with two type of message, that is request and reply. So in the request message, what ARP will do? ARP will add the source IP, destination IP, target MAC, destination MAC, source MAC, all these informations along with layer 2 informations, that is source MAC, destination MAC and type. All these informations are will start. So, like let me write layer 2 informations are like source MAC, destination MAC, type. Along with this, there are some layer 3 informations which is source IP, destination IP, target MAC, and the source MAC. These informations are generated by ARP, ARP request. Okay. Why it is generating such things? Because this PC doesn't have the target computer's MAC address. This computer's MAC address doesn't have. That is the reason why ARP is working for this PC to establish the connectivity. This is the very beginning step I am talking about. Okay, this act in a fraction of second, these operations would get resolved. But we are just trying to understanding this task because we are network engineers. Okay, so what happened? Why layer two data is there? Because this is understandable by layer 2 device. Okay, so source MAC is what? Source MAC is A. And what is the destination MAC? Doesn't have any idea. So FFFF, then FFFF, then FFFF. So this is the MAC address, basically 14 characters hexadecimal. Doesn't have. And type is ARP. ARP type. ARP type means ARP is basically doing this operation. And layer 3 informations is what? In the layer 3 information, source IP. Source IP is 10.1. Okay. In short, I'm writing destination IP is 10.5. How ARP knows? Because I have typed ping ICMP, right? That is the reason why destination is already added. Source MAC, source MAC A, destination MAC all 12 time. Okay, 1 2 3 4 5 6 7 8 9 10 11 12. So this is the size of a ARP request. Okay, this is the size of a ARP request. Just a minute. This is this is what it will travel. So once this request has been forwarded by this PC, this switch is a layer 2 switch. So in the MAC table, it will act as a VLAN number one. Why one? Because all the ports are by default remain in one group. That is VLAN number one. Now the source MAC. Source MAC is what? Source MAC is A. Is there any information about destination MAC? No, there is no any information. All are F. That means broadcast. Port means which interface, by which interface this information came, this ARP request is coming. So this is, let's assume it's a 0 by 1. Okay, it's a F0 by 1. Okay, and type means what, how what is the how the switch is learning this concept. So it's a dynamic, it's a dynamic way of learning. Okay, there are two types of learning by the switch, that is dynamic and static, right? So this is the first entry is made. Now switch seeing that this switch doesn't have any idea about the remaining part. Why? Because these are related to IP. Now switch is seeing, just watching the query and just trying to understand that what is the destination. So it doesn't have any information about destination MAC. So what switch will do? Switch will act as a unknown unicast loading UUF type of query will broadcast. What is unknown unicast flooding? So it is basically nothing. Switch will forward the query to all the interfaces. Okay. So once this PC will understand came the query of like request message. So this will is a layer 3 switch, a layer 3 device. This PC will understand what is written here, that is source IP, destination IP. So it will check source IP, okay, it is coming from 10.2. And what is the destination IP mentioned? 10.5. And my IP is 10.2. So it is, this packet is not for me. So I am sorry. This packet will be discarded right here. Same thing happened here also. My IP is 10.3 and the mention is 10.5. So sorry, this packet is not for me. Here also the same thing, because 10.4 is the IP here. But in this packet, in this request packet of ARP, hmm, mention is 10.5. Similarly, here in the server, this server will accept because the IP address is 10.5. At the same time, this server will see the target MAC address is remain 0. So don't worry, I will filling the MAC address. You don't have the idea, I am just giving you the solution. So my MAC address is E and I am just writing, I am just filling right here, that is MAC IP address and what, and time. So time is by default 1, that means it started. MAC address timer started. Okay, MAC means source MAC is A, destination MAC is E, and IP address source IP is 10.1, destination IP is my IP, this server is telling 10.5. Okay, so it's just filled up this query, this one, this thing has been filled here. Okay, and it is again replying back to the switch. Switch only understand first three lines. Okay, so earlier one in this destination MAC it was FFF. Now when this server is replying to the switch, the MAC address is what? MAC address is E, already written. So switch just understood the source and the destination. Accordingly, switch are forwarding this. This time reply is coming. Okay, the reply ARP reply is coming from the server. So reply will sending switch already know that earlier the request message came from this port. Now it is delivering the ARP reply to this PC. So once this informations came back to the PC immediately saved the database right here in its ARP table. So source, destination, everything, source IP, destination, everything been filled up. Destination this time is E. Okay. Source is already its own IP address. So once the ARP table is filled up, then the ICMP, which is earlier on handed over the task to the IP address, IP will check the ARP table. This time IP able to read the destination E, and once it is found the destination MAC is E and destination IP is already written, so it will send the data directly to the server next time. So at the very first time, switch will broadcast to get the MAC address of the destination. Once the MAC address is received, the next communication will be all in unicast. Okay, so directly it will send to the server next time. It will ARP will not act. I mean, ARP operation will not going to happen anymore. But yes, always remember the MAC address table maximum edge time is 5 minutes. So after 5 minutes, if this switch will not get any traffic from A, automatically the information will get flushed. So once it gets flushed, after 5 minutes, again this PC trying to reach to the server, what happened? Again the same operation will happen. Okay, same operation will happen. So as a network engineer, this is a big problem, right? So you need to solve this. How? Manually you can increase the time of the of this aging time of the MAC table. Okay, you can increase it. There is a command, okay, inside your packet tracer, and you can manually change it. Always remember there are two ways the switch used to learn MAC address. One is dynamic, is already written. Dynamic is an automatic process on the basis of data exchanging. The MAC address is keeping the information about MAC, and the another part is static. So we can, as a network administrator, we can manually make entry of a MAC address inside what? Inside MAC table of the switch. Okay. So this is the way, uh, this is the process the connection gate at the very beginning when the connection is initializing. Okay. So this is a very interesting thing. I hope you have enjoyed. Okay. So the video length is already half an hour crossed. Let me show you something. Okay. Whatever I have done here, let me, this is packet tracer, Cisco packet tracer. You all know that. And here you can see I have taken a PC just like uh, in the diagram, and I have taken one server right here. Okay, and here you can, I have taken a 1960 switch, and I'm just connecting these switches, okay, together. It will be a small lab. I just want to demonstrate in practical whatever I have done so far. See, okay, let's quickly configure the IP address. 192.168.10.1. This is the subnet mask done here. Shit. Put the sorry, desktop, and here 192.168.10.2. Done. Come here to the desktop. IP configuration 192.168.10 dot what? 3. And here 192.168.10.4. And in the server side, that is 192.168.10 dot 5. IP implementation is done. Now connection is established or not? Connection is not yet established. Why? Because no any traffic generated. Okay, traffic means what? I am not sending anything, right? Sending means what? Sending means data. I am not sending anything. So here you can see if I click on right here in the simulation, and if I generate a traffic right here, and I'm trying to ping this time 192.168.10.5 and pressing enter. See what happened. I'm not getting reply. Why? Because I have started the simulation. Okay, we are going to inspect each and every packet. Here see, two types of packet has been generated. One is ICMP and another see ICMP, and this one is ARP, right? So ICMP is basically what? ICMP is basically this one. I have generated a traffic. So ICMP just see request. It's a request and is waiting for the reply. It's generated the request, and ICMP then later on handed over the task to IP. And IP protocol is doing what? IP is just watching or inspecting in the ARP table. Is there any information about destination MAC? This is server. So not have by default, it will not get na, unless or until any first time the ARP operation will do one would happen, right? So by default it will not came. Here you can see in my real time in my PC, if I type ARP space minus a, enter, you can see, right? And the type static, dynamic. See, this is the ARP table, dynamically, automatically coming. It is manually happening. See, this is broadcast. So here let's understand step by step. See how interesting is this. What happened? So ICMP generated the traffic, but it will not travel. It will first travel the ARP packet. So let's send it. See, it is just going here in the switch. Okay, switch is not able to understand the source IP, destination IP. It is only understanding the source MAC. So it is coming from which port? Fast Ethernet 0.1. It is manually, automatically the information will stored in the MAC table. And how? See, if you go to the switch and if you click right here and if you type command enable and show MAC address table and press enter, see the information has came. This is the source. This is the source MAC address. There is no any information available for the destination, that is fast ethernet 0.1. It is coming from fast ethernet 0.1 and it is came as a dynamic way, right? So this is the MAC address of this PC. Okay, so this is what happened so far. Now this in this packet, destination MAC address information not mentioned. That is the reason why this switch will do unknown unicast flooding. Unknown unicast flooding means except this interface, all these remaining four interface, there will be a broadcast. This packet will be broadcasted and these three pieces will reject. Why? Because the destination IP is 10.5, not 10.234. So it will automatically get rejected. This server will accept. See the broadcast happened, and immediately this PC rejection rejected, and this server is accepting this one, right? Once it is accepted, it will reply. See, it is reply back. So once the packet came from here, it is replying. ARP query happened and getting the acknowledgement. So let's If you click on the packet, you can see this one. See, everything is inside. Okay, this is OSI model, this is layer 2, this is layer 3 information. Layer 3 is empty. Because why layer 3 is empty? Because there is no any layer 3 operation happening, because it is in the switch. Switch doesn't know about layer 3. So whatever is happening is source MAC, destination MAC, everything, ARP packet, everything, source IP, destination IP, everything is inside layer 2. But this switch is unable to read the last lines, IP and all. It will only get the destination MAC. See, if you now this time if you go to the switch again and if you press the same command, this time it will get the information about the destination, that is 05. This is 05, right? Now if you click on one frame back, see the ARP request came, right? It's given right means what? This ARP packet get the IP, get the destination MAC address. Now ICMP is ready to send. Okay. See, now ICMP is going and going straight to this server on the basis of destination MAC. Okay. Again, it is coming back and it is coming, right? Now let's go to the command prompt and see one reply came. So that is the actual operation of getting reply. In the real time scenario, if I type ping Google, see reply 1, reply 2, reply 3, reply 4 coming, right? If you constant get reply, press minus T and you constant get reply. That means what? ARP is done now on the basis of unicast type of communication. It is Google server is reachable. Okay, so this is the real time operation I have shown you. Okay, I hope you have enjoyed. This video is a bit lengthy, but it is a real time thing. Okay, I can't make it short because each and every information is very important for you. Okay, so thank you so much for giving your time to see this video. If you have any type of questions, you can use the chat box. Just drop the question and I will answer. And if you want any other videos as per your request, please write it down to the chat box, I mean in the comment section. I will try to make that video. Okay, so thank you so much. Goodbye.